So basically, the next thing I want to show you is how we do orthographics and put dimensions on things and make them, customize them. And if you're, wanted to try that, page 521 on the curriculum is where it starts. So I'm going to just say new, and I want a draft. All right, and so this opens up, and it defaults to a D-size sheet. And for those of you who've never been involved in mechanical drawing or creating these things, D-size sheets are pretty big. You're talking, blueprint size. If you're going to print in your classroom, you probably want an A-size sheet. So I'm going to show you a couple of things. And this sheet setup, so it's got a background of a D-size sheet right now. So I'm going to go into size. And so a D size is 34 inches by 22 inches. I used to work at a civil engineering firm, and we had printers and Xerox copiers that we could just drop sheets in and they would come flying right out. For our printers.
And Tom, isn't that 4 8.5 by 11 pieces of paper?
Yeah.
Side by side, 4 sheets of A?
Yeah, 4 sheets of A, and you're going to see that, all right, so we can do, for the most part, if you're using LaserJet in your classroom, which are probably the most cost-effective, printers, and your students will want to print a bunch of sheets, so it's always good to have them. So I'm setting this to an A, so it's going to be an 8.5 by 11, but it's A wide, so it's like a landscape position in your printer. And I'll say, okay. And so here's our A size sheet, but we still have the B size background. So we go back over here to our sheet setup, and we want an A sheet background. And now we have something that we can actually see. And we don't have a lot of room here, so we can customize this sheet. So if you wanted to come in to this sheet, we can always come back here and we can pick edit the background. And it tells us it's the background because, suppose this is a Word piece, and we can customize this for your high school, rather than, for Solid Edge. And, suppose I don't want to automatically pick my name, but I just wanted to type it in. So I could just go ahead and type my name in there. This is kind of a really pretty nifty thing to do because it'll pick the information, from the file as it comes in. So you want to make sure that that people are pulling in what they want to pull in. And so anything you don't want there, we can, delete the whole thing. And you can write in what you want to write there. And we can take things and just go ahead and delete them out. We can take whole lines and delete them out. When you get it the way you want it, then you can go ahead and save this as a template. And it'll be available for all kinds of things. Now, if you wanted to do a customized sheet for each size, and then save that so your students are always printing on school, background, then that's a great thing. So I'm going to close this out. And again, that's on page 521. And I'll start a new one. And in this case, I have the new, TW high school piece. And so now we are pulling things in. A-size sheet. It's got a nice border on it. For those of you who want to do, if you've got a laser cutter or a laser engraver in your classroom, generally you'll have good luck if you have a sheet, an A-size sheet or whatever. You get rid of all the background, so you've got a clean slate. Then you can put your views up there and tell the laser program what each line means as far as how deep you want it to cut. So that's a quick way to import things. I used to do airplane wings that way. We would design all the various ribs and spars and things, and put them on a sheet like this, and then we would cut them out and put them together. It's kind of a cool thing to do. So let me just pull out that train body. And basically, we have a parts library, and these, it goes back to the folder where you saved all your parts. And we can pull those parts in. So I'm just going to pull that train body in and drop it. And what it's going to do is it's going to tell me, all right, here's the front end. And if you look at it, it's kind of big for this sheet. So I can change my scale to whatever I need the scale to be. Let's go 1 to 2. And I can do a top view and a right side view. I can even do that isometric. And then when you're all done, you just right click and that says, okay, I'm all done. So now we can very quickly create those. So if you're thinking about, okay, I sketched it, it took me a half an hour with a pencil to kind of come up with a sketch, and here Tom did this in about 12 seconds, and it's everything is lined up where it's supposed to be. As we come back to these views, we can move them around if we need to, or we can change things about them, and we can make them a shaded view. And for example, if we take these and we come over here, shading options. We can, take a look at this and see which sides are where. All right, and then we can come in with our smart dimensions, for example. And when you put a dimension in, we've got the ability to change its size. And so you'll see drawings in the curriculum with big letters on them, because sometimes when you do these things for your students, you want to really highlight things. So, and that's how it's basically changed. I'm just going to make this back into 1. The models themselves are intelligent, and that's the whole reason why we do three-dimensional modeling, because it is a mathematical database. So if we have assigned materials to this, and I'll show you how to do that tomorrow, then when we create all these things in the drawings, it'll come in and it'll tell you what material it's made out of, where the welds are, if you have any, what your parts list is, and basically, this is how you do it, and it's an easy thing. So we do a parts list, and we can do that off a view. And if we had a place to stick it all. All right, train body, who's the author, et cetera, et cetera. So there are a lot of different things that we can do there. If you have a lot of holes, we can put a hole table in. And yeah. problem with demonstrating different things is they all climb in. So like for dimensions, we can retrieve the model dimensions. So if you look, all those dimensions that we use to create the part, are here. And then we can go and customize if we want. For example, I know there should be a center mark here in the middle of this circle. So I can just go up and say, oh, I need a center mark. And I can pick the center of the circle. And it makes it. And if something doesn't look like the way you want it to look, like if we wanted this particular dimension to be in here, and we know it goes to that center mark, I'll just back it up a little bit. So now we've got a little space by the center mark. I would do the same thing here. I want a little space by the center mark. And you see how we have this dimension up here? It's much better if I put it on the outside. So we can go through and customize this any way we want. And one of the things about this is, having the 0 at the end implies a few things, but it might be better to, say, okay, we don't need those. We're only going down to the 100th of an inch. And then, you would say, I only need 2 decimal places. So it would then change to, and it declutters your drawing a little bit. You might want to put a note on here. So we could make all fillets being, a 1/4 of an inch. That was the last one I had done, so it remembered it. So I can say, okay, and then I can say, oh, from the center of that. And so I can fully document in a big hurry what I've done. And so as you get through these, projects, you can have the kids document this, and then these become part of that engineering report at the end. And I'm going to show you a few other things tomorrow about other things that we can do to add to the, engineering report and have it come out.